Thank you very much, Antonio. Welcome all to this webinar on teaching statistics with large datasets. I'm Will Hornby. I'm the Subject Advisor of Mathematics and OCR, and also the Subject Development Lead for Maths and Further Maths for OCR, which means I have overall responsibility for the OCR development and also for our side of the MEI specifications as well. So today we'll be talking specifically about teaching statistics with large data sets, I'll just give you a brief overview of the three areas that we're going to talk about. The first is to give you an overview of large data sets, what they are, where they've come from, and what the idea is behind this new aspect of A-level mathematics. It's something that a lot of you will have seen in lots of presentations, so I won't dwell on it. My colleague Stephen Walker will have covered quite a lot of this on Monday in the OCR Maths A webinar, so you can access that recording as well. We'll then have a look at OCR's teaching and learning activities, which we've included in the specifications, an indication of the sorts of things that you might want to do with the large data set in the classroom, and then a focus on exploratory data analysis at the end, where we will do some work. I'll do some work with the large data set in Excel, and we'll have a look at some exploratory data analysis techniques, some ideas, some sorts of things that you might do with the data set. I'll try and leave about 10 minutes at the end for question and answer. I will keep an eye on the chat box, but with a lot of attendees at this session, it's not going to be possible to deal with all of the questions as we go along. And I'll deal with as many as we can. At the end, anything unanswered, we'll produce a Q&A document to cover it. Okay, so let's get started. So this is a brief overview of what large data set is. So the idea is that there's this large data set, a pre-release large data set, which you have for the whole of the delivery of the course, and it's designed to be used in the classroom. There's a few big things that we need to say about the teaching and learning or assessment aspect of this. So this is primarily a teaching and learning tool. We are required to assess whether or not students have used a large data set. It's a fairly low level quantity of assessment, and really it's a sort of a check that students have been using the large data set. Of course, they won't have access to the large data set in the exam. They won't have a computer, for example, to work with a spreadsheet, and so it is really about this teaching and learning aspect, what goes on in the classroom, and a hope really that statistics in the post-16 world might move a little, at least, away from sort of routine calculations, synthetic context, and a bit more into dealing with some real-life data. So the key message here about what goes on in the classroom is that the amount of time you spend on this, the level of integration that you make with a large data set into your stats teaching, the amount of technology used, and so on and so forth, really depends on your setting and your current capabilities and IT experience and so on and so forth. So there's no prescribed number of guided learning hours. There's no expectation that all of the content will be delivered through the large data set, or indeed that any of the content will be delivered through the large data set. You can use it in any way, shape or form that you like. What you need to make sure is that students are familiar with context and information from the data set in various ways, which we'll think about in a moment, so that in the assessment they can demonstrate that they've seen and worked with it at some stage. If all you can manage is one lesson half a term, where you have the large data set on a projector in the classroom and you're going through as a whole class activity, well, if that's what you can manage, then that's what you do. If you have laptops for every child and you can play around with it in every statistics lesson, well, that might be a little excessive. And there's a balance point in between somewhere. Okay, so it's about your setting and making it work for you in the way that it can. So in the exam, I've said that we need to assess whether or not students have used the large data set in the classroom. And the way that we do that is through this idea of material advantage. So this actually is a statement from an Ofqual document from the guidance, which gives 4 types of task which might then give material advantage to these learners. So 4 areas, they may assume familiarity with terminology and context of the data. They might use summary statistics, selected data and diagrams from the large data set based on samples related to the context of the large data set. And the key one for us, for OCR, is requiring learners to interpret data in ways which would be too demanding in unfamiliar context. Now, this is all pretty grey, and certainly you can look at the sample assessment material and think, well, actually, you know, with a bit of knowledge about the real world and what's going on, you can answer a couple of questions that look like they're on the large data set. And that's often the case. I don't want to go into the assessment items in detail, but you will find there's usually a mark or two in there which rely directly on knowledge of, say, terminology or context, details of the context, which you wouldn't expect 16, 17, 18-year-olds to know. And often the material advantage is more to do with familiarity. So enabling students to skim read the stems or to deal with large amounts of data and pick out from redundant data. So more about that in Stephen's webinar from Monday. Now, I don't really want to talk about assessment today. I want to talk about the classroom and what goes on in the classroom and how you might, what sorts of things you might do. So before we get on, this is a brief little screenshot of the OCR large data set to give you a feel for what it is. What we have is some data from census from 2001 and 2011, all 348 local authorities, and some data on methods of travel to work, which you can see here, and also on age structures within those local authorities. It's about 20,000 data points. It's quite a large data set, but because it comes in 4 sheets and it's all a fairly square data set, as it were, it's not an enormous amount. So that's what it is. And one of the reasons that we've chosen the census data is because it does cover the whole country. That's a good thing. And these sorts of methods of travel are things that students think about, traveling to school and traveling around the country and so on. And so it's at least a relatively familiar sort of idea. This large data set is intended for the life of the specification. So it's out now, it's on the website now, and will be used in live assessment. And we do need to retain the ability to change the large data set if we need to in the fullness of time. We find ourselves running out of sensible questions to ask, or the data becomes out of date if we end up with the specification for as long as we have had the current specification. But if we do so, then we'll give at least 2 years advance notice, and so that any new data set will come out before the beginning of any 2-year A-level course. We don't expect it to happen, but I just need to say that. Okay. So this is obviously a page of data. You'll notice there's a left-hand tab called the information sheet, and this is worth picking out. This is the metadata that goes with the data set. And when we talk about students being familiar with terminology and so on, we are, of course, talking about various fields. We expect them to have thought about underground, metro, light rail, and tram, and so on. But we do also mean various bits of terminology that come up in the metadata. So we would expect them to know, for example, there are 5 different types of local authority, what the word metropolitan means, and therefore what non-metropolitan might mean. And you also find in the information sheet some links to where the data has come from, the original census data, also some information about a few bits of tidying up that we've done, and to make the data sets comparable. So the information sheet there is a thing. It's not just for you, it's also for your students to get a sense of where this data has come from and what it is. So it's worth just highlighting. That's something to think about. So we're going to talk a lot today about what teaching with a large data set looks like. I just want to run through a few things that teaching with a large data set isn't. So the first thing is that teaching statistics in the new A-level math doesn't mean teaching with a large data set. This is part of the teaching and learning of the set of the course. And yes, whilst there are ways that you can deliver the content through the medium of the large data set, the intention is more that you deliver the content and then you apply it. You see how you can apply it into the large data set where relevant. The other thing is that the focus of the assessment and of this criterion is towards the data presentation and interpretation part of the specification. So there are lots of ways that you can use this large data set for looking at probability, at binomial, at normal, at hypothesis tests and correlation and so on and so forth. But the focus really is on that data presentation and interpretation section. So whilst of course you want students to use the full range of techniques in various ways, what we're really looking at is playing with a large data set and using those interpretation and presentation techniques. Teaching with a large data set is not the same as teaching with the large data set. And teaching with the large data set means with this census data, the original intention from the World Statistical Society, who sort of mooted this idea in the first place, was that we should be encouraging teachers to use real data and large data sets as a teaching tool all the time. And one of the ways that we do that is using a particular pre-release large data set that will then appear in the assessment. And of course, that is something that you need to work with. But it would be wonderful if you also spent some time looking at other large data sets in different contexts and use real-life data more in the classroom. Of course, there's no criteria, there's no assessment to require that, but that's sort of the intention behind this, is that this large data set is the one that you need to have looked at, but it ought to be a portal into looking at other things as well. Teaching with a large data set doesn't mean that all students have to have their own technology. So I did touch on this earlier. If you don't have access to much technology, if you say have a projector in the classroom and you need to work on whole class activities, there are easy ways of doing that. Or if you have access only to a small computer room where students need to work in groups, all that sort of thing, absolutely fine. It is worth saying that this large data set is certainly small enough in an Excel file to download onto a mobile phone. And I've played around on my mobile phone with Excel on this. There's things that you can't do. It's not brilliant, but there are ways that students could do that within even that small handheld technology. You can also, with graphical calculators, take a bit of that can take a bit of data. You can certainly put bits of the Excel sheet, or even in some cases the whole thing, into graphical calculators and work with it on that as well. But there's no need. This is about students experiencing working with the data and doing that interpretation and thinking about presentation techniques primarily. Teaching a large data set also doesn't mean starting from a clean spreadsheet every time. So every time you do a large data set lesson, no need to start from a clean spreadsheet and make them do all the work, all the donkey work. Otherwise, you'll spend a lot of your time teaching spreadsheets rather than teaching statistics. So whilst, of course, we'd expect students to experience putting in their own formulae and playing around with things, creating graphs, actually there's a lot to be said for starting with something set up with particular representations, particular tables or information, summary statistics worked out in advance by you. Here's a thing, now let's interpret and talk about it. And you can then focus on the interpretation side of things and discussion without having to worry too much about the nitty-gritty of where it comes from. So there's a balance to be had. Of course, we want some of the nitty-gritty, but we also need to make sure that we don't spend all of the time teaching how to use a spreadsheet. Teaching a large data set doesn't necessarily mean using a spreadsheet, of course. There are other ways, and there are other spreadsheets, of course, than just Excel. But there are also other bits and pieces, and Numeric is an excellent spreadsheet. It's free software. You can find that on the internet. One of the reasons why it's good is that it does box plots and histograms very nicely. So that's one advantage over Excel. There's also the GeoGebra spreadsheet, and some nice stuff like Tinker Plots, which is very easy to use data visualization tool. And for those of you who are a bit more computer literate or a bit more brave, there's always software languages like R or some more specialist software packages if you feel like jumping in and going the whole hog. So a full range of stuff. It's about using technology to interpret and use a large data set. It doesn't have to be about Excel. So having talked a bit about what it isn't, what is it? Well, we have these data set teaching and learning activities in the specification. These are in both the Spec A and Spec B math specification. And these are suggested activities. Make that clear. These are not requirements. This is not part of the specification in that sense. It's not content. But there are 7 things here, 7 ways in which we think that large data sets can inform and improve statistics teaching. So we have sampling, we have creating diagrams, calculations, hypothesis testing, repeated sampling, modeling, and exploratory data analysis. Now, these are only suggested activities. You can do what you like. This is a very free requirement, simply a requirement to work with. So you're not required to do these, but this is a starting point. And these aspects are the things around which we'll certainly, in the first instance, be developing classroom resources for you. Now, I'll have a look at these in groups. I'm spending a bit more time on some than others, and we'll aiming towards the exploratory data analysis activity. So while we're here, these lesson elements, since I mentioned classroom resources, these 2 lesson elements are available on the website already. So one of these is looking at statistical calculations, the underground metro light rail and tram systems, which does take you through some of that nitty-gritty of using the spreadsheet. And the other is repeated sampling exercise, looking at bicycle use in England and Wales. There's also coming soon a lesson element based on the exploratory data analysis type activities that I'm doing in this webinar. So that should appear as well. So more of these to come as we go through the summer and into the autumn, and then obviously more through the life of the spec as we develop the pedagogy and think about and work out how things operate. So the first group is basic techniques. So creating diagrams, calculations. So this is about giving students a spreadsheet and getting them to perform calculations such as finding means and standard deviations, and creating diagrams of various sorts. And not just, of course, doing the thing, but also thinking about what it is that they're doing, interpreting what's coming out of it, and evaluating whether or not it's sensible. And particularly when it comes to data presentation. If you're using something like Excel, it's very easy to create a whole series of really terrible graphs that don't tell you anything at all. So there's a skill involved in selecting useful presentations, and once you've selected some sort of presentation, in tweaking it to make it actually say what you're wanting it to say. So yes, basic techniques of creating things and doing things. Second thing is sampling and repeated sampling. There's 2 different things going on here. One thing that I want to pick up on here is that, of course, the large data set is a population. It gives you, nominally speaking, the whole population of England and Wales in 2001, 2011, and the data on them. So sampling does seem like a strange thing. Now, of course, sampling using the large data set in the classroom is not about working out information about the large data set, trying to estimate parameters or anything. If we want to know what the mean age is in some given local authority, we can simply find out. So when we talk about sampling here, we talk about really as a pedagogical tool. We have the population, and what that allows us to do is to try out, to explore sampling techniques, to practice sampling techniques, and to simulate multiple times lots of different samples, and have a look at, say, the variability within sampling and comparing different techniques and so on and so forth. And one of the reasons that we can do that is because we've then, of course, got the population that we can compare it to. So it's not sampling for the sake of sampling to find stuff out about the large data set. It's using the large data set as a pedagogical tool to inform students' understanding of sampling and how it works. You can also, of course, use to explore repeated sampling. And in one way that I've already mentioned, which is the idea of repeating samples, which could be as simple as taking a random sample, getting every student to take a random sample, get them all to make an inference about population parameters or about association or correlation, and then getting them to compare their results. Could be as simple as that. And of course, they'll come out with a range of results because they have a range of different looking samples. But it could also extend into students simply generating multiple samples for themselves to look at the variability within the samples and pick out samples that pop up that would lead to conclusions which don't actually match the population. And that's an important aspect of sampling to understand as well. We also talk about growing samples, about sample size. So taking a sample size 5 and trying to make an inference, taking a sample size 10 and 100 and 1,000 and so on. And the technology allows you to offload all that computation and do these things very easily. and not only very easily but repeatedly. So that's an interesting exercise as well. And I do want to mention jackknife and bootstrap. These are resharpening techniques. I apologise for the spelling error. I've just which in the case of jackknife, taking a sample and then taking out individual bits of data from the sample in a systematic way, and then finding the average of the estimate of the parameters that you get. Bootstrap are more about repeating sample, given a sample, taking small subsamples from it repeatedly to explore variability within the sample that you get. And it's a fairly sophisticated techniques. In fact, they're techniques that we discussed, including in further maths and statistics, and didn't end up going into various reasons. And I'm not suggesting by any means that you should do these in a formal sense, but simply having an understanding of how those two techniques work might help to inform the way that you use repeated sampling in the classroom with your students. Hypothesis tests. Now, there's a couple of sort of hypothesis testing and the modelling side of things. Again, this is about using the large data set for simulation. So it's about using the large data set as a tool, as a pedagogical tool for understanding how hypothesis testing and how making inference using hypothesis tests from samples might work. So we can carry out binomial and normal hypothesis tests using parameters from the large data set to create approximating distributions, and then we can simulate samples. And from that, we can then formulate hypotheses. And of course, we can formulate a hypothesis. We can then take a sample and see whether to reject or accept the hypothesis. We must, though, however, watch out for systematic bias. There's a real danger in taking a set of data, doing some exploratory data analysis, formulating a hypothesis, and then going back to that original data set to the original data set and doing a hypothesis test, because we get this sort of circular argument. So something worth picking out and discussing with your students. Another thing you can do, of course, is to do that exploratory data analysis, looking for formulating a hypothesis from a large data set, and go elsewhere to then look for different data or different sorts of data, which you could use to then answer those hypotheses. And last is exploratory data analysis, and I've left this to last because really this sort of brings together all of the other techniques. So I'll just briefly discuss what exploratory data analysis is, and it's the way that it relates to confirmatory data analysis. So confirmatory is the sort of thing that we're used to certainly discussing in the classrooms of traditional methodology, which is to say, I think I've got a true hypothesis, I've formulated a hypothesis, let's go off with a hypothesis test and find out whether or not it's true, confirm whether or not that's the case. Exploratory data analysis is much more about looking at data and seeing if it's throwing up any interesting relationships or patterns, about looking for hypotheses that might be formulatable or finding good questions. So whilst we tend to focus on the confirmatory, which is about finding good answers, if you like, it's worth remembering that we need to talk about exploratory data analysis as well, which is about finding good questions. Now, exploratory data analysis has been around a long time, of course, but popularised particularly by John Tukey, future data analysis and so on in the 60s and 70s. And we went into the stuff they did in the Bell Labs and developing R and S and so on. And it's about flexibility of approach. So it's about finding ways for data to express the apparent character that's there and using graphs as a tool for indicating the phenomena that are going on. So it's not using the graph as a presentation tool to say to somebody else, look, this is what's going on in the data, but using a graph yourself for the exploratory aspect of it, to make a graph so that you can look at it and see what's there, and see what's going on in the data. So when you're using very large data sets, of course, big sheets full of numbers, very difficult to infer things from. But the data visualization, therefore, is a key aspect of that. So exploratory data analysis is about flexibility and relying on display rather than formal techniques of calculating things and working things out, and a way of finding informal influence. Okay. So some of the aspects of exploratory data analysis that we can cover within A-level maths stacks, certainly the use of robust statistics is a key thing. So by robust measures, I mean measures that control for skew and outliers, so things like the median, interquartile range, and so on. So for example, if we have a data set, we calculate the median, and a couple of bits of data get corrupted. As long as they stay on the same side of the median stays where it is. And so it's robust to things like data measurement errors, and also to incorrect data or to strangeness that's going on. Whereas the mean, of course, is famously sensitive to things like outliers and to incorrect data. A single piece of data that's out by a magnitude of 10 will completely ruin a mean, probably won't make any difference at all to a median. So that's what we mean by robustness. And in some senses, it allows you to make inference about central location, or in the case of interquartile range, about spread, without being entirely sure about how clean your data is necessarily, or about skew, or about the length of tails or size of tails, the distribution that you're looking at. So the 5-figure summary, you'll usually lower range, upper range, the quartiles and the median, and box plots that come out of those are a key part of exploratory data analysis, because they control for these things like skew and outliers. Non-parametric tests are worth picking up on the way through. I've put in brackets further maths only. That's because there aren't any non-parametric tests within mathematics, but certainly within the OCR spec. We have chi-square tests, we have Spearman rank, and we have Wilcox and sign rank tests and so on. So these are things which perhaps I ought to have included distribution-free, of course, because Spearman rank is really a distribution-free test. So it's something that doesn't make any assumptions about the underlying distributions. The Pearson moment correlation, of course, relies on the assumption of binormality, whereas Spearman rank doesn't. So again, in terms of exploratory data analysis, we don't really necessarily know what the underlying distributions are, or we don't want to be making the assumption of binormality because it's not true, or we don't know. Then the Spearman rank is then this again, robust statistic not relying on distribution or not relying on estimating values of parameters. So that can come into further mathematics. There's no requirement to use a large data set in teaching of further maths, but if you're already doing it in maths, there are lots of ways that you can draw it into your further maths stats teaching as well. Another key technique is the plotting of small multiples. Now, by small multiples, we mean a set of graphs, we'll see some in a moment, a set of graphs which are related to each other, usually where some aspects, such as the year of the data or one of the axes is changing, and allows you to see variability across the data set very easily, and to understand complex multivariate data sets. And this is what we've got in this large data set. It is multivariate, and so these exploratory data analysis techniques are key in allowing to give your students an insight into what's going on with them. And dynamic visualization and animation is important. There are many ways that you can use that with this particular large data set. I've got a lovely example which I'll try and squeeze in with the last couple of minutes at the end of this session. But small multiples are really a sort of way of doing dynamic visualization anyway. But ways of direct interaction and animation are also good ways of reducing complexity and allowing ways of seeing the data set. So it's time to have a look at the example. So I will share my desktop here, and we see here, hopefully, you can now see the large data set itself. So we have this information sheet with various bits of metadata about things, about the geographic information, how the industry authorities work, and a method of travel, 2011, 2001, and then age structures. And it's worth just pausing on the age structures for a minute, because we're not going to look at them so much in this example. But there are some interesting aspects of this data, such as the fact that the groups aren't of equal width, and we have mean age and median age here for 2011. We don't have it for 2001, and the reason for that is that between 2001 and 2011, some local authorities have merged into unitary authorities. And so some of that data is sort of retrievable, or at least estimatable, from the original data set. Some of it's not, and leave it as an exercise to the reader to decide. And certainly it might be quite a good classroom activity to have to think about why it is that those aspects aren't there. And we can see as we scroll down that we have all these 348 local authorities. So it looks like quite a large data set. Once you get into working with it, it's really not that scary. So here are some bits of exploratory data analysis. These are things I prepared earlier, of course, in Blue Peter fashion, so that you don't have to sit here for the next half an hour watching me fiddle about and put formally into things. But no particularly sophisticated use of Excel here. One thing I will just pick out is on the Data tab up at the top, the data analysis tool here, which is worth picking up. I'll show you examples and output from that in a moment. While we're there, I've got Solver here as well, which is for LP, for linear programming. If you're teaching decision or the new discrete math, that can be a useful little tool there as well. So, first thing to have a look at is correlation. Now, this is an output actually from that data analysis tool. We'll zoom in a little bit so you can see better. And so what we've got here is a correlation table. This shows each of the fields in the method of travels to work data set against the others and the simple correlation coefficient, the PMCC in each case. Now this is using the data analysis tab. This is the correlation table itself that I've worked out. This is using Excel formula of various sorts. So using this Corel tab, and why there's no particular reason for me to have done that in the upper right rather than the lower left as here, other than that's the way I happen to do it. Worth picking out before we have a look at it, that before operating, this is not actually the original data. This is not absolute values. This is done on proportions, and quite a lot of the work that you do on this data set obviously uses proportion rather than the original values. The reason being that the local authorities are of different sizes, and so if you're looking at if you start plotting the actual number of people, say driving to work or passenger in a car, you end up with the small local authorities in the bottom left and the large local authorities in the top right. And you get all sorts of weird effects that you don't intend. So a lot of it operates on proportion. And these correlation coefficients are therefore on proportion. Let's just pop back to this one. So the caveat here is that, of course, a correlation table like this doesn't give you anything robust. This is not about looking at correlation tables and producing hypothesis tests and so on and so forth. This is an exploratory data analysis technique. It's simply about producing a whole wealth of different correlation coefficients and seeing what jumps out, because it allows us, out of this complex multivariate data set, to pick out the things of interest, the things where there might be an association. I've color-coded this. I've put in some conditional formatting because that allows it to jump out even more. So of course we can see a diagonal line of ones because they're all perfectly correlated against themselves. That's not very useful. But you can see driving the car or van against underground, metro, light rail, or tram coming out as a pretty strong negative correlation here. And there are all sorts of reasons that we might want to posit about that, such as good infrastructure, leading people to use those forms of transport. Of course, those forms of transport are primarily metropolitan, so you tend not to be wanting to drive a car in a city if you've got those sorts of things available. There are also pretty strong negative correlations, passenger in car against that, and even driving a car against train. You're going to need to think carefully about what we mean by a strong correlation coefficient, because of course we're used to dealing, certainly in teaching available maths, with pretty small values of n, in which we want to really be picking out 0.8s and 0.9s to say that there's much going on. However, here n is 348. We've got an awful lot of data points, and actually, if you start looking at your critical values of PMCC, you'll find that 0.3, 0.4 is actually a pretty strong effect. So we can ignore some of the ones that are a bit smaller than that, but actually these 0.4s are pretty interesting. So these are all negative. There are some positive correlations going on here as well. It's not particularly surprising that driving a car or van associates pretty well with passenger in a car or van. That's not massively surprising. But there's all sorts of things going on here. We mustn't also forget that we tend to look at the tails on correlation tables all the time, but actually some of the small ones are interesting. The fact that taxi and train essentially have no correlation is an interesting thing. So this is a correlation table. Now, having done this and thought about, well, maybe there are some interesting relationships going on here, we oughtn't to go off and do anything until we looked at some scatter diagrams, and here we get into small multiples. So, what do we have here? These, I shouldn't have zoomed. There we go. So what we have here is for every local authority, which is why each one of these is a pretty dense cloud. For each local authority, we have the passenger in a car or van up the left-hand side, and the method of driving a car or van up the left of the vertical axis, and all the other bits and pieces along the horizontal axis. So what we're changing is the variable that's being plotted, or the field that's being plotted along the horizontal axis. And so we can instantly pick out the different forms of correlation going on here. We can see that strong correlation, passenger car in a car or van coming out, and we can see some of the negative correlations there as well. Now, this is about using scatter diagrams as an exploratory tool. We're not trying to make any strong conclusions from this. We're simply using them as a way of having a look at the data. And one of the things that we need to pick out from this is the dense clouds in some places. I'll zoom in and just have a look at some in particular, so you can see what's going on. For example, an underground metro, light rail and tram, it looks like there's not an awful lot of data there, but of course there's 348 data points. The fact is that they're all squished up here against that vertical axis. So what's going on? Well, the fact is that most local authorities don't have this as an option. So actually finding a correlation coefficient off the whole population is pretty stupid, because we have different subpopulations going on. So this jumps out immediately as somewhere where we have different subpopulations of local authorities which have different types available even, and perhaps we ought to be looking at those as separately. If we look at work at home, one of the other things that we can do with these small multipliers, certainly in an exploratory form, is to look for outliers. And we often look for outliers to decide whether to keep them in the data set or not, that sort of idea. But here they're really interesting, because what we have is these clouds of data points, often which show that a lot of local authorities sort of work in the same sorts of ways. So it's an interesting thing when we get an outlier that jumps out and says, hang on a minute, there's something going on here. And if we look at work mainly at or at home, there's a point right the way over on the right-hand side here, where between 30 and 35% of people are working at or from home. You might have a think to yourself momentarily about which local authority that might be. And it's the Scilly Isles, where of course a lot of people aren't travelling very far to work at all. And we'll see them pop up in other places as well. And the next one down here is West Somerset, which actually is a perfectly reasonable place to travel out of and to, but still nearly a quarter of people saying that they work at or mainly from home. Something else to pick up here, if we come across, is on bus, minibus or coach, we have an outlier tucked in here where almost nobody is travelling by car or by bus, and again, of course, that's the Scilly Isles. But up here we have lots of people travelling by bus, and we'll find that those are metropolitan areas of some sort. Other one I want to pick out, don't want to spend too long here, because we've got a few things to do before we finish, but if we look at bicycles, again, a very dense cloud up at the top, and some real outliers out here. Now, it may be no surprise to those of you who know Cambridge, but this outlier at nearly 30% is Cambridge. The next one in is Oxford. The next one in is our dear friend the Scilly Isles. And we then get into places like Hackney and Islington, where clearly lots of people travel by bicycle. They're probably not going very far. and we get into sort of urban areas of various sorts. So so that's what's going on there. Last one I want to pick out is on the on foot. We have an outlier way down here at nearly 45%, and it's not the Ciliars. The Ciliars is back up here, but it's of course somewhere very densely populated. It's the City of London. So we can use these outliers as a way of gaining some insight into the way that these geographies work and these ideas work. And the last thing as we go, our dear friends Ciliars, of course, on other methods of travel to work, 30-odd% for other. I like to think that's probably boat, or certainly in 2001 when the helicopter was still going to Penzance, we learn a little bit about the Ciliars there. Okay, so moving on, I'll just stop sharing. Oh, I'm sorry, I've not quite got there. I will share back again. Something else worth picking out. We have these small multiples, and of course we can take out some of the data. So we're only looking at a particular region or a particular type of local authority or sub-region. One of the other things we can do is use bubbles. Now, here what I've done is I've added a column here saying weight, and I've added a little criterion here to where I can put the name of the local authority, and in the weight it simply says if the name of the local authority is what's in that box, make that value 10, and otherwise make it 2. And we can use the bubble chart on Excel to give us those same small multiples, but with the eye of the silly picked out. Now, all we have to do, change this to somewhere else, let's say Nottingham, and we pick out Nottingham. Anything interesting going on in Nottingham? Well, there's a fair amount of tram to do with the tram. Otherwise, a fairly tedious place in terms of this last data set, I'm afraid. But there you are. That's what you get when you pick a random local authority. So, but you can then, of course, you can drill down into various different places, pick them out, and see what's going on. Two more things quickly. This is our output from this data analysis tool. It creates very quickly for you a whole range of summary data of various things. And I always think it's nice to not only find ways for students to compute things that they need to know, like the mean, standard error, and median, and so on, but also, for example, the word standard error, which is not something that they have to come across, but it does them no harm to have seen, and things like kurtosis and skewness, which are not measures they need to know about, but again, just these little tidbits of the real world, as it were, of real statistics, are popping in there to give you some ideas. Similarly, confidence intervals. This is further mathematics only, but having confidence intervals there and that idea helps to build in the idea of variability and of spread. Last thing to have a look at is bicycles. Now, this is an indication of how the exploratory data analysis can come out of just simple calculations. This is 2001 and 2011. We've got all categories of people in employment, the number of people travelling by bike, and the bicycle percentage then. We've got them ranked by percentage. We've got absolute changes, percentage change, and percentage point change. The difference between those, if we had more people coming out of school knowing the difference between percentage change and percentage point change, that would be a great thing. And also rank difference. So various ways of looking. And again, I've shoved in some conditional formatting so that the top 10%. Trying to work out what the measure was. The top 10% are green, and the bottom 10% are this sort of pink colour in each category. Now I've sorted them by 2011 ranked by percentage. So we do have Cambridge, Oxford, Ardsley, Hackney popping up here, and you'll see as you go down that actually South Cambs comes up again. But otherwise, we've got more or less lots of bits of London and some decent-sized cities. You may well find, of course, if you do a little topological study, that you find the flatter cities at the top. Sheffield, for example, isn't turning up anywhere near there. If you scroll right the way down to the bottom, you'll find that the ones at the bottom on this ranking are mostly in Wales. Which is clearly either not a good place for cycling because of the hills or because of the average rainfall. All sorts of reasons that you might postulate. But this is then very easy to play around with because we can use the sort. We can do a custom sort. We can sort these, say, on 2001 ranked by percentage. That's column H. And do it smallest to largest. And suddenly we've got them in the other rank, and we can see where people have appeared or disappeared. It'd be interesting to know what happened in these various places, mostly in the East Midlands between 2001 and 2011, East Midlands and East of England. Why did everybody suddenly stop riding bicycles? All sorts of things we can pick out here. Okay. Now, there are all sorts of interesting patterns and things I've spotted demonstrating this over the last few 6 months or so. I won't bore you with all of them, but there's a whole wealth, even in just this simple calculation spreadsheet. So that's a little taste of exploratory data analysis. The last thing I want to show you is the use of animation. And very quickly, we've got about 10 minutes left. So if you've got some questions, please do start thinking about questions, getting them typed up, and shove them in. And we'll just have a very quick look at this. So this is Gapminder, and Gapminder is a really nice tool. This is their trend analyzer tool. It's a brainchild of Hans Rosling. If you've not heard of Hans Rosling, do look up his TED Talks. They're absolutely brilliant. Do Google him. And the major value of this, to say large data set is not even getting close. This is a truly vast data set. And an enormous value of this is being able to use dynamic visualization across long time series. This is something our large data set doesn't do very well, so here's a very easy tool. Now I've set this up with life expectancy up here, urban population share down here. We've set it at 1960, and we can simply have a look at this and make some sort of informal inference. What are we seeing? What sort of trends are going on? You can see this sort of bottom left to top right trend. Expect places with a high proportion of urban population to have longer life expectancies. It's quite an interesting question to say, can you pick out where the large countries would be, or the heavily industrialized countries? And things aren't actually quite as straightforward as you might think. And the ones up at the top are, in terms of urbanization, are of course very small city-states. So we have Singapore, and we have Macau, and Belgium, interestingly, drops out, but otherwise Malta and Hong Kong, and so on. So these very heavily, and Qatar, so very heavily urbanized city-states up at the top end. And actually, the sorts of Scandinavian countries you might expect with high life expectancies are along here, up along the top end. What we can't see here is the size of the populations. That's because I've changed I've got rid of this these bubbles. We can add in bubbles here which show the populations, and now it jumps out at you what's going on. So why am I doing this? Because this is a way of dealing with multivariate data sets. A scatter diagram only gives you two fields against each other. If we start using bubbles like this, we can get a third. In fact, we can get a fourth here because we can very easily add in, for example, no, that's not what I'm after. Well, we can very easily add in some other colours. We can add in heat charts of income per person, so we get low income per person down at the bottom of this sort of green colour, and sort of orange colour with high proportions up here. So it's very easy. We've now got 4 dimensions going on in our scatter diagram. Very easy to add things in. The other lovely thing that we have here is this animation. And so here we go. If I press play here, it animates us through the years from 1960 onwards. It's going a bit slowly. We can see a general drift up towards the top right as places get more urbanized and life expectancies go up. I'll just run that again quickly, because you may see that there are some countries out there which are bucking the trend. So let's just run that again, and if you let your eyes unfocus slightly, you can see points which are charging off in various different directions. Even one that's gently drifting off to the left here, which is Trinidad for some reason. If we slow the animation down a bit, we can pick out, actually, you can see fairly major world events popping along. This country that's just dropped down is Nigeria, the 70s. Got, wow, something going on over there. It's Cambodia. And in Vietnam we've missed. We can see Live Aid. Here we go, this is Ethiopia. And as we come through the 90s, here we go, yep, something just dropped down. This is Rwanda. Of course, we're not picking out very nice events here, Eritrea. And we should see Haiti in a moment. There we go, there goes Haiti. And Indonesia, of course, around the Boxing Day tsunami. So we're not picking out very nice events. There's a certain braveness that you have to take in the classroom using this sort of data, because of course you're going to pick out various difficult things. And you can pick out, you can use the trace function on this as well. Where is Cambodia? Let's concentrate on something really horrible. If we pick out Cambodia here, you can see it slowly increasing in urbanization, and then through the 70s, you have this horrendous drop in life expectancy and, of course, in urbanization. There's lots of things going on to pick out, even in this single animation. Things like Haiti and Indonesia both suffering these big population losses, but Indonesia doesn't really show up in the data. It's very difficult to spot because there isn't much of a change in life expectancy. So that's an interesting thing to try and pick out. The Channel Islands have a general continuous drop in urbanization across the period. So that's an interesting thing. Maybe we could look at island nations and see what else is going on there. UK basically sits in the same place on urbanization. Of course, that's because our rapid urbanization period was before the data set, before 1960. So lots of things. If you have the opportunity within your setting to do some cross-curricular work, working with something like Gapminder, or indeed our own large data set with history or geography teachers, might be very interesting. Interesting ways of working and thinking about stuff. Okay, so I better wrap up there because we need to leave it there. So I'll just run through the last few slides. Thinking about planning, these are more general planning things. We have this teaching order framework, which is a complete solution to maths and further maths. All 4 options, completely co-teachable. So that's on the website, worth having a look at. The scheme of work builder, mapping documents, checking tests, which are topic-based tests, going through all the overarching themes for each topic. So including, of course, statistics and data presentation and interpretation, not focused on the large data set. We're focusing our efforts there, certainly to start with, on lesson elements and ideas for what's going on in the classroom. Those are the 2 large data set elements that are already on the website. Sets of practice papers will have the first set of practice papers out by December 2017, which of course will give you a few more assessment items, and the second set by Easter 2018. So you've got at least 2 sets to go into that first session. CEP books, of course, they're supporting large data set CEP through their Cambridge Elevate resources, their online resources. Hodder are doing a similar thing here as well. Okay, more information here, and we have more webinars through this week, 2 more today, and so on. These are some face-to-face events. We'll include some large data set work here. This is some of these given by me, some by Stephen, full day, hands-on things, doing some mechanics activities, doing some large data set stuff. In the afternoon, doing a bit of further maths as well, looking at some schemes of work and co-teachability and so on. So if you're planning to teach OCR, please do let us know. It's always useful for us to have the data so that we know who's out there and who needs support, and who might like resources and what's going on. So let's tidy up some questions. And see what we've got popping up in the chat box. We've got one here. Will OCR be creating similar resources for the MEI spec? We may create some resources for MEI spec, but while we deliver the assessment and administer the assessment for MEI, it's MEI do their own support and resources in general. So do go along to the MEI website. There's already a wealth of resources there for large data set, and their integral tool is definitely worth signing up for, whichever specification you're doing, and that will include large data set activities as well for MEI. So So there, and is the spreadsheet available with the extra tabs? So this spreadsheet, I'll get the spreadsheet sent out to you as delegates, so you can have a play around with those extra things and the bits and pieces I've already done. Please don't just use those tabs that I've done in the classroom. I mean, feel free to use those, but please do develop your own stuff as well and think about what you're doing. One more here. Several schools are telling me they're delaying choosing an example until they've tried out each of their data sets. Do I think it should be a deciding factor? Well, that's an interesting question. Certainly, it's one factor. It's a relatively small part of the assessment. There's nothing to stop you using any of the large data sets for any of the specifications in the classroom. There's a way of learning statistics and learning to think about statistics. So, well, why not use all the resources that are there? But I think if you're thinking about the large data set as a deciding factor, it ought really to be the approach in the assessment, I suppose. But it's a relatively small element for any of the ordering organisations. So I wouldn't have said it was a massive deciding factor, other than that you're going to have to use the one that goes with the specification that your students are sitting. So you know, if it's an interesting and useful resource that you can do lots of good things with, then that's going to be more fun to work with than others, perhaps. Certainly, yeah, one comment there saying you plan to use all the data sets I can get my hands on. And of course, there are other real-life data sets out there, but the ones that come from the awarding organisations will have resources that go with them. So I think our approach in the OCR Spec A is trying to be nice to students. We're certainly not intending to create assessment items that have silly tricks or little tiny bits that assume that they've done particular activities or know particular things about the large data set, other than that they're familiar with the fields, they've played around with the ideas, and that they have some idea of what the terminology and context mean. Okay. So if there aren't any more questions, it is 1:15. If you have any more questions, do please send them to us at maths@ocr.org.uk. I hope you found this session useful. I have one last thing from Julia, which I would like to pick up. As a solitary lecturer in a college, I now feel more daunted by the prospect of delivering this instead of more confident. I'm wondering when I'll have time to prepare adequately to deliver this starting in September. So I will just reiterate from earlier that the amount of time you spend delivering this depends on your setting, your experience, your knowledge. If it's one lesson every half term, or you know, a couple of linked lessons once a term, that's fine. That's all that's really required. So it's enough for your students to gain a familiarity with the context. If you can spend more time exploring and playing with this, then of course that's a great thing for your students. But the requirement is just that sort of minimal engagement with it, enough to understand the context and terminology. So they will be tested, but it's fairly small. In the OCR spec, it's 1 or 2 questions. It's definitely in the single figures of marks. And within those, most of those marks are accessible to any student. There's usually, we reckon, a couple of marks where there's a clear material advantage to students who've seen the terminology and context before. So do please have a look at the sample assessment material. It's on the website, and you can see the level. It's definitely present there, but it's not something to worry about greatly. Okay, so we've run out of time. Thank you very much for coming. I hope you've enjoyed it. It's been a pleasure to deliver. There are 2 more sessions today. We have a use of technology session, and also Stephen Keane from Science Studio is doing some myth busting on calculators at 5 o'clock. Both of those are great sessions. And I hope to see some of you on Friday in London. Thank you very much.